And we are live. And we already have some viewers. Hi, everyone.
Hello.
I'm Pasha, as you can see, and this is Dmitrii. Dmitrii, do you want
Yes.
to introduce yourself?
Well, I work at BellSoft, and I work on multiple things, including OpenJDK, and also you can see me at different conferences and now on live streams.
Okay, and what do you do for BellSoft? Like, you obviously speak at conferences. Is it your main job?
It's just a part of my job. Engineer. So we do different things in OpenJDK hotspot virtual machine.
Okay, this is very nice. Since we are live for like a minute already, we can probably call out our audience. Dear viewers, please say hi in our chat and tell us from which location are you viewing, just so we know our geography and that you are actually alive and the whole machine actually works. And well, while we are waiting for the comments, let's say why we are here. We are actually just back from I see. Hello from Balkans. Hi, Masha. Interesting. Is it only me or Dmitrii actually disappeared? Folks, tell me if you see Dmitrii there. Okay, so we are just back from JVMLS. What happened?
I saw my connection dropped. Never
I
mind.
see. Yeah. Masha says that she sees me, nobody saw you. So Dmitrii disappeared for a second.
That's a jet lag.
Surely. This is how it should be. Yeah, and Dmitrii is back. Nice. So, Dmitrii and I are just back from JVMLS. You can't see it, but I actually have my case unpacked behind me. It's behind the coach, which is behind me. Did you already unpack your cases?
Yes, I did.
You're much faster than me, but okay. To be honest, you came there. You came back earlier than me. You came back there like a couple days ago.
Just on Monday. Yes.
Okay, so I came back on Wednesday, and yes, it wasn't JVMLS that long. We actually Dmitrii went to a couple of meetups in Boston, and I went for a meetup in Seattle. How did your meetups go?
Very nice. We had a Drivers Group gathering in Burlington, and I had some pleasant time in Boston. And in general, that's nice. So at least I had my plane on time, no rush, and
The most
sometimes.
important, okay, the most important question: were you robbed in your hotel?
Everything went smooth. Just
This is amazing. Okay, my time in Seattle was actually also very good. Okay, we have some audience. Let's jump back into JVMLS. JVMLS this time was 2.5 days. And these 2.5 days, it was like one track, which included talks, workshops, and a panel called Ask the Architects, right?
yes, but workshops were split it into two tracks.
Yeah, right.
That was kind of as usual. So that's what usually happens. There's one track for presentations, and workshops are split it in two tracks. And the panel is also a kind of traditional.
Attendee? Oh, the traditional thing. I see. Traditional thing.
Yes.
Do they actually have it always? I don't remember. I don't even remember if we had it the last time.
Yes.
Okay,
There was
good.
panel discussion.
What was your favorite, and what were your key? I don't know, key takeaways.
I would say the overall program lets you understand the big blocks that make the overall direction where the platform is going. So I would say, besides language talks, so we had 2 talks, one talk about Clojure, and one talk about Kotlin. Besides that talks, basically all the rest is about the platform, JDK, OpenJDK, and there are like 3-4 big blocks that blocks change from year to year. So this year is like 3-4 blocks. Some are related more to the JVM specific, some more to the language, but they actually all connected, and different topics they let you see that work from different angles, but sometimes even different projects, they help to solve some common issues.
I think
For instance,
the last
for
year.
instance,
Oh,
yeah.
sorry, please.
There's a big goal to have that integrity by default in OpenJDK, and then defines many things, and it also is related to that old issues about serialization and how it's implemented in the Java language. And now it changes slowly, and things are probably going to be painful, and some libraries will break. Their older versions will break, or legacy versions will break. They will need new implementations for newer JVMs, or users will get some migration paths that will let to maintain some transition period, to focus on their code and integrating new versions of that libraries. I mean, for example, serialization. And now that thing will be called, probably will be called marshalling and unmarshalling.
It's very interesting because marshalling already exists in the JVM platform. It is, well, it used to exist in the JVM platform, but it
You
was
mean
a thing
.NET
in
platform?
XML, right? You could marshal and unmarshal XMLs. Now XMLs are not the part of the platform, if I remember correctly. JavaX XML is now moved to Jakarta XML. I think so. And the reference implementation of it is array, right? Eclipse does the reference implementation, which is very interesting. I just read a huge long message in developers list there yesterday that folks, I know that you are the reference implementation of Jakarta.
Oh no, things just are going so fast after Corba removal.
Yeah, this is true. And we had a question about Corba just like a week ago. I don't know if you saw it, but we've actually got this this question after
No, I haven't.
Baruch's and mine webinar.
So what was the question?
It was something like, we are going to use this Corba implementation with library GDK. What do you think about it? And I was a little bit lost because, to be honest with you, I have never used Corba. I had to Google it a lot just to answer this question. It was like an actual 1-hour research to understand what is this all about. I thought that for me, Corba was just a protocol, something like gRPC of the old days. It actually is something like gRPC of the old days, but it had a lot of Java-specific things like RMI, which stands for remote.
But it is so common because it's named, common. C is for common.
Well, I could know better. I didn't know it. But even when we are talking command, like there is JSON RPC these days, which is a remote procedure invocation or remote procedure call, sorry, which essentially does the same, and it doesn't have the name command in it, and that's fine. Okay, what I was going to tell actually about serialization is it looks like to me that current implementation of serialization is not going anywhere for at least for some foreseeable future, because the new serialization won't actually be able to replace the old serialization. It has a very well-defined set of limitations which make it severely different from the current implementation of serialization. Is it your understanding too?
I think it will be replaced. It's not an issue. If you have an alternative way of doing the same thing, and probably it will be an alternative way of doing the same thing, it will be replaced by usages. And the new scenario covers both third-party libraries and things which happen within means of OpenJDK. So why not?
The good thing here is it's actually designed to be extensible. You probably can plug on your own serialization format, and as long as its format or it's compatible with the specification, it will just work. For example, like a simple idea, you can probably plug your own JSON serializer, potentially. No one is saying that it's a good idea.
There are challenges, as discussed even during the talk. There are known challenges, and I had a question about the approach to how we perceive some unknown data as a stream of serialized objects. So current serialization, it covers some interesting good cases where we have version mismatch, and it's covered by serial version UID comparison. So you can, for example, determine that you are getting a newest version of the object that you don't support as a receiving party. And in that case, you can just say, "Oh, okay, it's a valid process of deserialization, and we just don't know what we are deserializing, but we know that's a valid serialized version, but just we don't support it." And in that case, it's possible to fail fast, and probably in deployments like Kubernetes, where different versions of services are quite typically mixed. That makes sense. There's a question if serialization makes sense there at all, but sometimes I think it is. But maybe the proposal that we heard during the talk will be somehow extended. For me, it would be like easy to imagine some versioning added to the schema of your marshalless, which is a great thing. Your data format is covered by some schema. That's what we love about XML, right? But it's not XML; it's generic. So that may work. You can add some version.
Actually, I see different. I just come up to the bizarre example of where marshalling potentially, or serialization 2.0 can potentially stop working. The whole Spark framework, which is for distributed computation, relies on serializable lambdas. Every lambda should be serializable there. And serialization of lambdas is kind of interesting beast because there is almost no data to serialize. And the way that real lambdas are actually serialized in JVM is, let's call it interesting. I'm not sure if with the serialization 2.0, it will be still the case if lambdas would be able to serialize at all.
That's interesting because they're not objects.
And the lambdas can be serializable though. And function 1 and function 2, and so on, whatever they're called, producers, consumers, do they inherit serializable these days? I believe they do. I don't know, but they're kind of objects. They're very weird objects, but they are objects. They also can capture data from outside, which is very important. Wait, why are you saying they are not objects? They can capture data from outside.
You can create an implementation. You can create object that inherits the functional, implements the functional interface. But if you create Lambda, it's not, in fact, an object. Well, it's interesting.
But wait, if my Lambda captures an object from outside, isn't it an object?
You just capture the object. That's it.
I'm being told that something is wrong with my... Sound better now. Catherine, thank you for that.
Yeah, you sound better now.
Sorry, everyone. Okay, hope I sound better now. So
yeah, let's just check. I don't remember, honestly. So consumer, no, nothing about serializable. Just say functional.
So Spark has its own magic to make Lambda serializable. I mean, I guess they
as well as many other frameworks. They use some insecure stuff, right? Or the stuff that breaks integrity, which is fine.
Wait,
so the platform is accessible enough.
Let's explain it. Let's explain it. What does it mean? Breaks integrity. The idea is when I deserialize something serialized, I usually have to somehow set the values of final fields, which is impossible with usual methods. So I call something like set accessible true on them.
Which might not have a public constructor.
Yes, so I mean,
some
theoretically, I do restore all the fields but transient ones. And they usually do not have public constructor, so I call reflectively set accessible on them, set accessible true on them. And then through reflection, I assign a new value. And in current serialization implementation, JVM does this hack itself because JVM has access to all your data, and it can do it without even unsafe and so on.
And that's a common mechanic. So if you allow that happening, that means you allow any usages of such functionality in your program.
You mean as soon as
open door?
You mean that as long as set accessible true exists in JVM, anything can break any part of the program, right?
To the trusted model. It's open. It's open.
Sorry, I lost you. Can you say it again, please?
So someone may use that functionality.
Yeah, someone may use this functionality, right? This is what I'm saying. And it is potentially dangerous. There is a huge philosophical question if you should stop something like that or not. Because, for example, Python lives in the assumption that all the developers are adults and everything should be accessible. If a developer wants to change something, it's up to developer. And I mean, it's a valid philosophy, obviously, and Python is very popular, and its popularity only grows, which tells good things about Python, I believe. But in Java, philosophy is different. In Java, philosophy, to me at least, sounds like let's make it safe. Let's make safe thread safety, safe concurrency, and so on. But for that, we have to introduce a set of limitations. And because of that, we have private fields, final fields, and so on. And also final fields.
It's not just safety, it's also performance. So if you know that some stable values are stable, you can optimize how they're treated with the effectively compiled code and all that. And in our Java world, we have many sophisticated companions to the code.
Yep.
All the libraries, all the agents, right? Agents are also being more restricted nowadays. They become more restricted, but still they can, if they are permitted, they can modify your code. They can try to add some goals that change things, and we thought they're stable. So we will have that guarantee. Probably that would be better. That thing bothered me and still bothers me for all the time since I figured out that final things exist in Java. Second, you figure out that sometimes they're not final, and some magic happens under the hood. And
I was
that
approaching
may be,
this.
especially for newcomers. So you learn some concept, and then you learn that's actually opposite, or that's counterintuitive, right?
Yeah, I was approaching this. It's not only about safety, it's also about performance. And regarding finals, there was a separate discussion on JVMLS about final finals or stable finals or whatever they are. And if I remember correctly, please correct me if I'm wrong, but there is another JEP in the makings right now, which will define how we can, that we will have something like a wrapper over a value, which is called, which will be called presumably stable value. Do I remember correctly? You are muted, by the way. Stable value generic, which looks like, I don't know, thread local or something like that.
Yeah. Okay.
Shoot. I lost you again.
Yeah, it's a new API, a new fashion, which is somehow, if you saw scope values, for example, this is convenient.
And it enables optimizations again, because JVM won't let you change even reflectively nothing inside stable value. So even if you try to change it, like with set accessible true or something like that, you won't be able to, and it will enable some kind of optimizations. For example, if I understand correctly, scalarization will work better. Am I right? Can you hear me? Dmitrii? You're muted. What?
Yes, that may be the case. It may be the case. Sorry, I was muted because the sound was ripping for me.
Are you saying that I'm echoing? What's with the sound?
No, it's fine.
Okay.
No,
We
it's-
also had a language section, and I'm very happy about it because the last time Charlie Nutter told us that it is supposed to be a language summit, and there are almost no discussions of any languages but Java. So this time we had two talks, one about Kotlin and one about Clojure. And Clojure highlighted a very interesting approach. They said that they use new Java features very, very conservatively. They are not rushing to support them. And they talked and they told us how they support virtual threads. And if I understood correctly, the idea is somewhere inside the language there will be a switch. Like if this platform supports virtual threads, we will try to use virtual threads. Otherwise, we will just use traditional threads.
Well, that's the part I didn't get. So I need to recapture the talk because to me it was like probably a newer version will support all the recent stuff, and
yeah, it was mostly a talk of
it's likely
they support it.
A newer JDK to run.
Yeah,
I'm-
absolutely. So the whole talk was delivered by a person from Nubank. I don't remember their name. I can. I can actually find it right now. Give me a sec. Closure. Yeah, so at least the last name was Miller. The first name is not in the program. So it was a talk how they implement support for features. It doesn't mean that they have it already. And as far as I understand, Nubank is a huge company which can't just implement support for new feature. They have to thoroughly test it. So they have implemented some kind of internal switch that will enable them to either use or not use support for virtual threads.
You see, that's an interesting part. So it's a big working critical system, right? It's a banking, some part of banking industry, and the demand and the goal of using such languages is to work with immutable objects, basically, right? Some immutable data, which makes it safer. And that's what's happening in Java. That's a useful tool which is missing. You can't easily create totally immutable data, piece of data.
Yeah, it's actually harder to create mutable data than immutable.
So that's why. So to me, that was an important part of this story. Is why Clojure lives there. Why it's being developed, invested in. And yes, there are certain aspects of having this production more effective, making it more effective. And sometimes there's a huge amount of legacy code that relies on your platform, language platform. But it's also true for Java. And in that sense, a different talk, not about language, but about a slightly different JDK, about AJDK from Alibaba. It's also related to virtual threads, where for all the versions that JDK has a copy, like if you run JDK 8, it can automatically switch platform threads to virtual threads for you. So the application won't notice, it will continue running. That's interesting. It's somehow similar to what happens in Fuse JDKs, like Liberica Performance Edition. There are no virtual threads, but our other functionalities are replaced in a similar fashion.
Wait, what? Liberica Performance Edition can detect when you need to use virtual threads and switch to them, or
no? It doesn't have virtual threads.
Okay, but
so that's the part that's not like in AJDK.
Okay,
but it's interesting that it is possible to go beyond that and also to adopt virtual threads and even make automated conversion, right? So the application won't know, but it will probably have some benefits, at least some types of applications.
It could be, by the way, very interesting optimization theoretically to detect that there are like only IO calls inside the thread, and then just switch this thread to a virtual thread in Performance Edition, even though there is no such API, but it could be a huge internal optimization potentially. I guess it's almost impossible because you would have to solve the halting problem. But other than that, to me, it sounds exciting. Oh, this thread only does HTTP calls. Let's make it a virtual thread, and they will win something. I don't know if it's possible. It's for you, probably for you to decide.
Yeah, another aspect on that talk was the story about tooling that lets you to investigate individual hiccups in your workflows, though it's not publicly available. So it would be interesting to try that, I would say.
Another thing that was discussed from several aspects on the JVMLS was Project Layden and its future. Where are we now and how it improves? And it was, to be honest, one of the most interesting aspects to me, because Well, currently Project Layton is already what we have. What I tried, OpenGDK 25 early access. It's pretty impressive. It actually saves a lot of startup time and maybe renders some other technologies more or less useless in this regard. Not at this point, but the future, like if I understood correctly, there are a lot of optimizations that are possible to enable, and more and more things can be saved into these AOT caches or JSA archives or something like that. And who knows, maybe in like several years, you would be able to replace crack, if you use crack or native image, if you use native image only to improve startup times with a Project Layton. What's your point of view on it?
So I would say the set of things is limited if we talk about some internals. And here the unknown dark matter is maybe there are possibly things from user space, from libraries that can be stored or could be stored in the archive. That's actually can be solved already, right? So we can cache something in memory, dump it to disk.
Yep.
In its realized form, right? And then quickly restore it on restarts.
Yep.
But if it would be done for any data automatically, that would help. But again, it's some state if we look from the application perspective. So the clear vision Project Layton right now is to have a stateless implementation of some caching between restarts of the JVM, and stateless from the application's perspective. And if we try to keep any caches between application restarts from the application standpoint, we save state. Otherwise, well, we should carefully look at it and see if it's safe to save and restore it. What happens if some circumstances change, like if the time is quite different on the system where we restore the saved snapshot.
I know. So this is what we learned this lesson from Project Track, right? You can't save you can, but it's potentially dangerous to just dump the memory to a hard drive and then restore it, because all your credentials are there. I don't know, a lot of things might be in there, and you have to implement smart ways to erase the sensitive data and then somehow restore it. But as long as you're saving compiled Java classes and probably JIT compiled Java classes, you can do almost anything until you save the actual data, not from inside JVM. I'm not, and it looks like quite possible, isn't it? Like if you have a constant defined on startup, then yes, you probably will have to recalculate it every time and de-optimize a small part of your code. But a lot of, if your method is in line inside another method, you won't need to de-optimize it. And your JVM is already semi-hot, let's call it warm. Do I get it correctly?
Well, the general move there is to have solution not just for the startup phase, but for the warm-up phase of the application. But it has much greater potential because the warm-up phase is much longer. It's not seconds, it's probably minutes, tens of minutes. But it's harder as well, because there are many different scenarios, and the warm-up happens, real warm-up happens not in the same environment where startup happens.
What do you mean by real warm-up?
The real warm-up is a process when your application responds to some real load, which means you either have to simulate it specifically for that process or to put the application into production environment, while startup happens without any real load, right? It's the process. There's no clear definition. By the way, Dan Hedinga greatly had a very powerful preface on that. So let's say the startup is the process of getting up to the first request, right? So we're doing everything else. We prepare stuff and we are ready to process a request. And then we start processing slowly. So it requires time to get to the peak performance. But this getting up to the first, to the point where we can serve the first request, it can be performed in some isolated environment. We don't need any actual connections involved, incoming connections. So it can be done in CI easily, doesn't require any specific training load. It's not so easy for your warm-up phase. But letting you to bypass the warm-up phase is much more promising at the same time.
Let's make it a little bit more grounded. Usually in real application startups, Hibernate class path scanning takes a lot of time. Like I'm running my Spring Boot application, launching it, and like for 3 seconds, it tries me how it tries to find and load beans, the entities and so on, initialize entity graphs, whatsoever, and so on and so on. And there is a lot of job like this. WebJars try to do something like that. They probably still do something like that. They need to scan the class path to find all.
Well, they don't need to scan it in runtime, right?
But they do. But they do. So my question is, can we optimize it with Project Layton now or tomorrow? I mean, I guess it's possible to do it.
Well, it depends on how you. Well, some parts of it, like class not found cache, help to address that. But in general, this is a user level story. So if there would be a way to introduce some state safe caches on that data, right? That's probably a candidate.
But it is possible
to support.
Hibernate will always resolve the same entities. On every run, it will find the same entities. Well, until you change a set of entities or change of fields in these entities, obviously. But it's not like Hibernate will find suddenly a new entity which didn't exist on the last try.
But you actually can perform this work ahead of time.
But they do. But they don't.
Yep.
But
yeah, that's the question to library
Gavin
solvers.
King.
Yes.
Yeah, I mean, I know, but the world is not a perfect place, and as long as we are saying that this is up to library developers,
no,
it
you
won't
have
solve actual pains.
It really annoys you. You can use crack and save all your state.
Yep.
You'll get it resolved. So you'll start from the point where it's already resolved. But again, this is a part of startup. I won't say this is a part of warm-up. Yes, it probably still continue happening during warm-up, right? You hit some new cold parts of your data, graphs, and whatever. But it's mostly one-time operation. With the cold warm-up, it's much more complicated. We all know that tiered compilation is very sophisticated, and it requires a lot of running data, many repetitions, many paths that your code has taken to compile your code. And if the guesses were not quite correct, they're not optimal, the code will be de-optimized and you'll get some bad latency for some time, and up to the time when you recompile the code again. So
It makes
sense. That's
so
a different
it is
form.
possible to do.
Yes.
Even if Leiden can't do it today, it probably will learn how to do it tomorrow. But I have another question. What if at the time of startup or warm up, before the first request, my applications creates a socket connection to something, gRPC connection to another service, or just a client for some service to read data from it continuously? Will it be possible to optimize somehow with Leiden, or all the passes that lead the execution to this socket will not be optimized? Because it's obviously impossible to save socket in the archive. It just doesn't make any sense.
It's a state.
Everything is state in a way.
Stay stateless. So no, it's a state of your kind of user mode part. Just your state of the VM part. It's like what's up with your code, what's up with your classes on all the linked data, how they are related to each other. So that's your JVM state part. That will be shown.
Nice.
The more interesting question is when it will be available, and how close is the current implementation to be usable. How easy is it to try? And surprisingly, now it's very easy to try. There are different EA builds, the very much stable code in the development branches. And the overall experience is getting better. So with AOT cache and with Leiden, it's easier to use the feature. That's important, because the concepts may be quite complicated, quite challenging, especially for anyone who is not Java focused. Like say you have different applications in your environment and you have to treat Java very specially to make it run effectively. You start with your heap options, which is probably an extreme overhaul for many of platform engineers.
Okay,
you have to deal
everything...
with snapshots or caches. It's even more complicated.
Thank you so much. Everything we discussed so far.
What we have to remember is it's not in Java 25, right?
Yes.
So that's
things we are discussing right now are kind of future.
The material. Yes.
It is. I believe it's not before Java 27, which will be released after the next JVMLS, obviously. But this whole time we discuss, Dmitrii, you disappeared, by the way. This whole time we are discussing JVM only features, but I was excited about another feature which is much closer to actual users of the language, actual developers. It's not as deep, and it's very, very user-friendly. It's about new numeric types and type classes in Java. And to me, it was exciting because I'm coming from Kotlin. I was in Kotlin very long time. And you can define, for example, plus operator on almost anything. You can define plus operator on lists, on strings, on whatever. And it won't be in Java to the same extent. You won't be able to define plus on anything, but probably at some point there will appear an interface by implementing which you will say that this class is, let's say, numeric. It's a complex number or a vector or something like that. And it is possible to add one vector to another, or it's possible to multiply one vector to another by another to some extent. And to me, it was really, really cool. Probably it won't appear before project value classes will be implemented, if I understood correctly. But after that, well, Java can suddenly become much more friendly to developers by my definition of friendly. You can have your own nice operators on your own classes. Dmitrii has a comment.
Well, it's not a big issue. So Java exists for so many years, 30 years, without having arbitrary operator overloading. And I had a feeling that everyone agreed that as soon as that proper algebraic overloading will be available, people will start using it for arbitrary overloading instantly as soon as they would be able to do that. Though anyway, to me as a mathematician, the concept looks entirely right. So you just see.
Also, you're saying
this
that
is a kind
fine.
of right structure we are going to stick to here. So this type allows such kind of structures. Here are operators, and in its core, algebra is very simple, right? So it builds new and more complex constructs on top of very, or it tries to, on top of very simple constructs. So the notion of a number in mathematics, it can be defined in in many ways. But every way tries to keep it very, very simple. Like let's start with an empty set, right? That's sum 0. And imagine a set that contains an empty set. That's 1. And there's an operation of going from.
Wait, what? What did you just say? A set which contains an empty set is 1?
Yes. That's, for example, a way to define natural numbers.
Okay, it kind of makes sense, but also kind of doesn't. Because in Java world, it's a set of sets at this point. New set to which you pass list of sets, which is empty.
No, just stick to the most primitive concepts you can invent. So all the theory of different operations and all that nice theorems and practically usable results are based on very simple definitions. So they must be minimal, because if they contain something that you actually don't need, that means it's wrong.
Okay, I'm actually playing dumb here.
But at the same time, keep it complete. So if you say this is a ring, then it must conform to all the properties of a ring.
Ring is simple, field is slightly more complicated, I would say. But yeah, like I'm playing dumb here, but I actually know something about algebra. Probably not because I'm a mathematician, I'm not a mathematician at all, but I read something about category theory, which is in this sense very close. Like they have all these simple definitions. We have monoid, which is a 0 and an element and one binary operation on them, which is always defined the same way. And something else and something else. And we actually heard all this stuff during the talks. The beautiful thing is, for some time, I've been doing some game development. And actual game development in Java becomes very, very fast because you need to have linear algebra here because the whole graphics is about linear algebra. And it is so hard to do without operator overloading, to be honest. I mean, at least for me, you have to define every function in some static class, utility class, and then use it. And it becomes a mess so fast. Also, one time I needed to implement a cryptographic function on big integers. And it was a huge chain of big integer operations, almost unreadable to a normal person, to be honest. Because it doesn't translate directly to pluses, minuses, and so on. Well, it kind of does, but you have to be able to rewrite it in your head. So you're reading an algorithm on a paper, and it doesn't match the code in your editor, because your call in your editor is a mess. It's a chain of operations which is nothing like mathematical operations on the paper.
Well, you know what to do. Just write a compiler for the main specific language into the.
I mean, these days this compiler is called Kotlin.
Yes.
These days this compiler is called Kotlin C, but soon-ish it will be available in Java too, hopefully. Obviously, linear algebra package won't be a part of standard library. It's not obvious to be. Yeah, I explicitly asked this question, but I expected this answer.
But you must think of some reasons behind it. That was clearly discussed in the talks on the Language Summit. So there are some practical challenges. Like, let's add a primitive type. And if you try to add a primitive type to the language, you immediately have that combinatorial complexity of extending the specification. You must define all the casts, you must define comparisons, rounding, etc. So
you're talking about float 16, right?
Yes, but there are other examples as well. And your types might behave differently depending on the library. So let's let libraries add them. Just the language is trying to help libraries to do that, to keep that correct, to keep readability for users. So that's a great move. And the mechanics behind letting users to redefine, overload data operators is the same as with marshallless and unmarshallless, at least as it has been proposed, is to use that witness methods or witness classes. Which
it's hard to express witness classes here. Just talking, we probably need to show some snippet, but you can just Google the whole data.
The basic idea is very simple. You have to keep your operation symmetric. That the example that was named is equals operation, which allows you an asymmetric implementation in Java. So A may be equals B. A may equal B. A dot equals B is true, and B dot equals A is false. That can happen in your Java program. You can easily write such a program.
Yep.
With two different classes, with two equals implementations, and it's kind of trivial. So the honest solution is to have someone third who decides are those objects equal or not. That's what happened with comparators, and the same approach can be generalized to be used with other operations.
And witnesses are a part of Valhalla again. So a lot of new upcoming things.
Are
will-
they?
I guess they are, aren't they?
I don't think so.
What are they part of them? Amber shouldn't be.
So you don't need any value type mechanics to have that.
Wait, but are you saying that Valhalla is only about value types?
But they are related to nullability properties of objects.
Which is a part of Valhalla again.
Yes, which is a part of Valhalla.
I was under the impression that if Valhalla depends on something, it immediately becomes a part of Valhalla. Am I wrong?
No, but the dependency is the reverse, I think.
Okay, we are almost out of time. So probably we should summarize a little bit. There were talks on JVMLS on different topics. Valhalla was, there were very interesting discussions of Valhalla. There were, Project Babylon was discussed, as you said, custom numeric
Yes,
types together
models,
with,
yes.
sorry?
And code models.
Yes, code reflections.
Yes.
Code reflections is a part of Project Babylon. Custom numeric types together with operator overloading were discussed, and they are very, very close. Witnesses were discussed, and it was very interesting. There was a couple of discussions of different languages, Clojure and Kotlin, how Kotlin will benefit from Valhalla when it's implemented, and how Clojure language builds on top of virtual threads. And in general, it is, as the last year, I was there only 2 times, JVMLS is an amazing way to try to look into the future. It's not what's happening, it's not what's happening now. It's not what's released in Java 25 and goes to the next LTS. It's more about visionary things and understanding why something is, why something isn't, and how people define what will be and won't. And
yeah, by the way, it's a great time to try Java 25 because now it's in release candidate state.
yes,
So you can
please
try.
please download Java 25. And if you find any issues at all with your workloads, let us know. It is very important and it allows us to do Java better. Do you have anything to add?
I
guess
it's
no.
time to yes,
Folks,
yes.
if you have questions, we have maybe a couple of minutes. Otherwise, well, it's time to say our goodbyes and see you next time. I don't see any questions. Timo, wave your hand.
Hi, everyone who said hi. We read you.
Yes,
Yeah.
we are reading you. We are happy to see you here. Thank you very much for coming. See you next time. Bye-bye.
Bye-bye.